Welcome to solverfy.
In this question, we are looking at a sample of gas that is emitted, and it is made up of different mole fractions of certain other elements. And we are trying to find how many metric tons of gas of these elements are emitted every year. So for this question, we're going to be using PV is equal to nRT. And we're looking for the number of moles of these gases. So N is equal to PV over RT. They tell us that the pressure for this reaction is equal to 1 atmosphere. They tell us that our temperature is equal to 298 Kelvin. I'm going to be using the R value 0.0821 liters atmosphere per mole Kelvin. Alright, so let's first find our volume. So V is going to be equal to 1.5 times 10 to the third meters cubed. And let's get this into liters. So I know that 1 meter cubed is equal to 1,000 liters. So this is going to equal 1.5 times 10 to the 6 liters. All right, so let's find the total number of moles of gas that we have. So N is going to equal 1 atmosphere times our volume, so 1.5 times 10 to the 6 liters. We're going to divide this by R, liters atmosphere per mole Kelvin, times this by our temperature, which is 298 Kelvin. So when we calculate this out, our total number of moles is going to be 6.13 times 10 to the 4th moles, and this is total for our gas. So to find the number of moles for each of our gases, so that way we can find how many tons are emitted per year, we need to use our mole fraction. So our mole fraction is going to equal our number of moles of each gas divided by the total number of moles in our gas. So for our first gas, which is CO2, so it tells us that our mole fraction is 0.4896 for CO2. Just to get the number of moles, we're just going to times this number by our total number of moles. So we're going to times this by 6.13 times 10 to the 4th moles. So our moles of CO2 is equal to 3.00 times 10 to the 4th moles. All right. And I know our molar mass of CO2 is equal to 44.0 grams per mole. And to get metric tons, we're going to use 1 ton is equal to 1,000 kilograms. So our mass of CO2 is equal to 3.0 times 10 to the 4th times 44.0 times 10 to the negative 3rd, because I divided this by 1,000 to get it into kilograms per mole, and this is equal to 1,320 kilograms of CO2. So to get this mass into tons, we're going to just divide this by 1,000 kilograms per ton. So we have 1.32 tons, and they want us to find out how many tons are permitted in a year. So we're going to take 1.32 tons, and we're going to times that by 365. So this is going to equal 482 tons per year of CO2. And that is how many tons of CO2 would be produced per year. So now I have all of the other gases written out. So we basically, for every single gas, we just take their mole fraction, which is given to us. We times that by the total number of moles that we found in our sample. And then we take the moles of, say, carbon monoxide, and we times that by its molar mass, divided by 1,000 to get it into kilograms. And then we divide the kilograms by 1,000 again to get it into tons. And we times it by 365, so that way we get how many tons are emitted per year. And all you're doing is just switching out the number for the mole fraction for each of element or compound of the sample and using its molar mass. And that is how we calculate all of these. We just use their mole fraction with their specific molar mass to find how many tons per year of each of the elements in the in the sample.